Hi, in this video we're going to look at taking vectors and resolving them, getting a magnitude and an angle and turning it into a column vector, mathematical column vector that we can then use to solve equations and do all that good stuff later. Really important topic. It's going to be useful in statics, dynamics, kinetic particles, anything with forces, moments. We're also going to use the same idea in projectiles in 2D or maybe even constant acceleration in 2D. So very, very useful. Let's go through it now. Bit of theory, a few examples, and sort this out. So if you were one of my students, you would know this very well. I have something called the triangle. Of course, I know there's more than one kind of triangle, but this triangle appears in mathematics so much. A right angled triangle and sine, cos, and tan come from this triangle, of course. Let's discuss these, perhaps in a way you haven't thought about before. It's going to help us resolve these forces in a second. So let me just label this triangle. Let's call the horizontal one x, because it's kind of in the x direction, x coordinate. Let's call the vertical one y, because it's in the y direction. And then let's call this side r, because if we imagine this was like the center of some axes, this would be like a radial line coming out from the axis. It's part of the unit circle and stuff. We can talk about it more later. But right now, let's just call them x, y, and r. Sine of theta we know is going to be equal to the opposite over the hypotenuse. Cos theta we know is the adjacent over the hypotenuse, and tan theta is the opposite of the adjacent, so nothing new there. What I'm going to do now, though, is set this r equal to the number 1. It's going to make things very nice for us, right? Because if this is a 1, then this is a 1, and this is a 1, and now sine theta is just the same thing as, well, y, because y over 1 is just y, right? So this is just sine theta. Let's change that to write down sine theta. And of course, x over 1 is just x. So x is equal to cos theta. Put cos theta here. Why is this triangle so useful? Well, imagine I had a triangle that was just a bit bigger. Same angle here, but rather than being a 1 here, let's say it's now 2. So I've taken the 1 and doubled it, right? Which means I've doubled all the sides because it's just a similar triangle. So this would be 2 sine theta, and this would be 2 cos theta. But it doesn't matter what number I chose to do, right? I could choose, rather than a 2, I could choose a 10, say. I put a 10 here, so it's going to be 10 times bigger. So it'd be a 10 there, and a 10 there. And if I change the angle, say the angle wasn't theta, but say it was, I don't know, 20 degrees, then of course these thetas just change to be 20 degrees. Why is that useful? Well, we're taking a vector and writing it out as being an x part and a y part. So I could write this down as being I'm going across 10 cos 20, I'm going up 10 sine 20. Plug those numbers in the calculator and you'll see actually what the amount is this way and the amount this way. You're taking a magnitude and angle and giving yourself a column vector, which makes our life easier when we come to solve questions later. So now let's practice doing this, but for different questions. The important thing to recognize here is that all you need to know is which side the cos is. The other side is going to be sine. So I would say the one next to the angle is going to be adjacent to the angle, therefore it's going to be cos. And the little phrase we use is 10 is cozying up to the x direction, so it's going to be cos in the x direction. That didn't quite make any sense. Don't worry. Let's look at a few questions now and see if we can make it make more sense by doing some examples. This first one, 10. So you can kind of imagine the triangle drawn out here. This side is going to be next to the 30 degrees. This will be cozying up to the x-axis. So I'm going to put 10 cos 30 on the x direction. This bit here will be 10 cos 30. And then the opposite here is going to be 10 sine 30. It's the same triangle as just done, but rather than being 20, it's now 30. So 10 cos 30 on the x, 10 sine 30 on the y. The only last thing we need to look at is sines. So since this is going in the positive x and also the positive y, we can see that both the x and the y part are both positive, like coordinates, right? It's in the positive, positive part. So positive this way, going towards the right, positive this way, going upwards, a positive, positive vector. Let's try another one. Down here, again, I can draw a triangle in for you, but I don't necessarily need to. And that's what I have a vector for it. So start with cos, it's next to, it's cozying up to the x-axis. So it's going to be 20 cos 40 on the x-axis, which means the other one is going to be 20 sine 40. I mean, I could write in here 20 cos 40, and I could write in here 20 sine 40, and perhaps you want me to, but I don't particularly need to. Doesn't change what I write down here, right? Now signs. It's going positive in the x direction, but negative in the y direction. It's going right, which is positive, and down, which is negative, right? So positive sign here and negative sign here. You can see this coordinate here would be positive for x and negative for y. Positive, negative. Let's try the next one. Triangle, we could draw it perhaps here so it contains the angle this time. This time it's cozying up to the y-axis. The angle's next to the y-axis rather than next to the x-axis, right? So we're going to get 15 cos 20, but this time that's in the y direction. So I'm writing the cos on the bottom here rather than the top because it's next to the y-axis. Again, we could write in here, this is 15 cos 20 if you like. It's the same picture, it's just been rotated, right? Let me take it here. We just copy this picture, put 20 degrees here, put 15 here, put the 15 cos 20 just there. And you can see that if I just turned it round, then I've got the exact same thing, right? It doesn't make a difference that it happens to be 90 degrees switched. It's the same exact format as we had over here. Cos goes on the x here, but because it's now rotated, now cos is going on the y. It's cozying up to the y-axis, so it's in the y direction. That makes the other one 15 sine 20, of course. If one's cos, the other one has to be sine. I could write it in here if you want me to. And think about signs, plus and minus signs. So here we're going upwards, so the bottom is positive. We're going towards the left this time, which we know is negative. We can see that this coordinate here would be negative in the x direction and positive in the y direction if I was plotting coordinate up there, like it was in year 7 or something. Last one. I could just draw a triangle again, but I don't think I need to. Maybe stop drawing triangles eventually. I can see we're cozying up to the y-axis here. So w cos theta is in the y direction, which means the other one has to be w sine theta. We can see that it's going down, it's going left. So both of the signs here are negative. Let me make some room for my minus signs. Again, I could draw this out for you. This is w cos theta here. If it's next to the angle, so it's the adjacent. So w sine theta is opposite the angle, so it'll be sine. Hopefully you can see that this is useful. If you had several forces acting on one object, you could work out all of them as vectors and start messing about with adding those vectors together to work out the resultant force, which is what we're going to do next set of videos, next options. Just to recap in case this is a bit confusing, because some people are going to be happy with this and some people are going to be a little bit lost. The key thing here is it's supposed to be like 10 cos the angle, 10 sine the angle, whatever the force is cos, whatever the force is sine, then the angle lasts, right? Don't confuse which way around the numbers go, okay? The angle's always going to come after sine or cos because you sine cos angles. The only other thing you get confused by is whether you put sine on top or bottom or cos on top or bottom. Remember that if the angle is next to the x-axis, it's cos on the top because it's next to the x, cos on the x. It's cozying up to the x. Here, it's the angle's next to the x, so it's cozying up to the x. Over here, the angle's next to the y. That's why I'm putting cos at the bottom, because it's cozying up to the y direction. The adjacents are y here. The adjacents are x over here. And then signs, plus and minus signs. Make sure you look at which quadrant you're in to give a plus or minus sign. Okay. We'll be using this more for next video, so if you're not sure, check that one out, and maybe the more times you see it, the easier it'll get. Thanks for watching. Hope it was helpful. Check out the next video.